Hey everybody, welcome to another support video. This one is to go over the sheet that I gave out called Understanding Linear Functions version 6. If you're in my class, just use this to correct and understand the process for each of these problems. If you're not in my class and you happen to stumble onto this video, it's just how you can, first of all, write y equals mx plus b or slope-intercept form for a linear function given to you on a graph. And then also where those linear functions might intersect. We call that solutions to a system. So if you're trying to figure out how to solve a system of equations, I'm going to give you a couple strategies to do that as well. So anyways, let's get into it and see how to do this. So the first thing you're doing when you're identifying line number 1 here, recognize that it is a positive slope. As you guys can see, it goes up from left to right. So that's a positive slope. Remember, slopes that go up from left to right are positive slopes. Slopes that go down from left to right, like this one down here, are negative slopes. And if it's a flat slope, like it's just going along straight, right, not going up or down, that means as x increases, y stays the same. That means the slope is 0. And if it's a vertical slope, meaning it's straight up and down, you can't really tell whether it's super positive or super negative, so we call that undefined. Okay. Anyways, long story short, let's just jump in here and label some of these ordered pairs. So the first thing you want to do is you want to label this ordered pair here. So that is going to be an x value of -5 and a y value of 3. So this is going to be -5, 3. The other one you want to label here is this one right here, which is going to be an x value of -2 and a y value of 5. So that's going to be -2, 5. So once you've labeled your 2 points, the next thing I would do is look for the slope. Remember, the slope is the staircase of movement along a line from one integer ordered pair to the next. It really works from any ordered pair on the line to the next, but generally we're talking about from an integer to an integer just to make it easy for ourselves to calculate it. And so when we're doing that, we're going to basically say, what's the change in the y direction? And that's basically going to be the value that goes on top of the ratio. And then you're going to have the change in the x direction, which is going to be the variable that goes on the bottom, or the value that goes on the bottom of the ratio. So change in y over change in x is another way of thinking about it. So from one point to the next, you're going to go up 2 and to the right 1, 2, 3 units. And since we're counting by ones, that just means +2 for the change in y and +3 for the change in x. So change in y over change in x, this is a slope of 2/3. So the ratio of movement from one point to the next is 2/3. Okay? And so once we understand that, basically what that means is that as x increases by 1, y increases by 2/3, right? As x increases by 1, y increases by 2/3. Or from one point to the next, up 2 to the right 3. Once we have the slope, then we're going to just take the slope in one of the points and figure out the y equals mx plus b for this line, or the standard slope-intercept form of the line. And like we said, it was a slope of 2/3, so m is equal to 2/3. And the order pairs that we have here, the first order pair is -2, 5. So we'll use that one. You could use either pair. It doesn't make a difference which one you use. I always use one to find the equation, and then the other one to check to make sure I have the right equation. So you have an x value, a y value, and an m value. We know it's y equals mx plus b. So just plug into that so we can solve for the y-intercept, the b value. Okay. So we have the value of y is equal to the value of m, okay, times the value of x, plus whatever the y-intercept is. And so in this case, it's 5 is equal to -4/3 plus b. And that's the same as 5 is equal to -1 1/3 plus b. Just add 1 1/3 to both sides, and you will get the answer for b. So this line should cross the y-axis at 6 1/3. So we think that the universal line here would be y equals the slope, 2/3, times whatever x is, and then plus the y-intercept, plus 6 1/3. Okay? So there's our equation of our line. And let's just check to see if that's reasonable, right? Does it look like it crosses the y-axis between 6 and 7 at about 6 1/3? Yeah, that looks pretty good. You can see that's about 1/3 of the way between 6 and 7. So everything seems to fit. Let's check it with the other point, which is -5, 3. So we're just going to do a little check here. And the way I do it, I'm just going to do it mentally, just make sure that my answer is reasonable. And that was with -5, 3. So 2/3 times -5 is going to be -10/3. -10/3 is basically negative 3 goes into 10 3 times. Yeah, 3 goes into 10 3 times with 1 left over. So basically that's -3 1/3. So it'll be 3 1/3 plus 6 1/3, which is going to be 3. So yeah, that works perfectly. All right, cool. All right, now let's do line number 2. So for line number 2, this is going to be a negative slope because it's going down from left to right. So I think we can all see that. Let's pick blue for this one. Once again, start by identifying 2 ordered pairs on the line. So you've got negative 1, 1. And the other one that you've got here is, oh, cool. We have the y-intercept. That's awesome. So this one's actually really easy. We already have the y-intercept of 0, negative 3. So we know where it crosses the y-axis. So we don't even need to worry about the equation too much. We can just do that by looking at the line carefully. And then this one is the one we can check with, I guess. This is 1, negative 7. Okay. That's, yeah, pretty cool. All right, so we know it's going to have a minus 3 in the equation. So y equals mx plus b. The b is 0, negative 3. So we're going to have minus 3 in the equation because it crosses the y-axis at negative 3. All we got to do is figure out the slope here, right? So what's the staircase of movement? We know it's a negative slope. It looks pretty steep. So it's probably a negative slope with an absolute value greater than 1. The change in the y value is down 1, 2, 3, 4. So change in y of negative 4 is you're going down 4. And then change in the x direction is to the right 1. Okay, cool. So what you're going to do there is you're going to have the ratio of negative 4 for your slope. Because basically, as you go down 4, you go to the right 1. As you go down 4, you go to the right 1, and so on and so forth to get back to the line. So this one's an easy one. You don't have to do a lot of math for this one. You know that the answer is going to be y equals negative 4 times whatever x is, and then minus 3, because that's just the line right here, right? It crosses the y-axis at negative 3 and has a slope of negative 4. Once we have that line, just pick any of the points to check it with. So I'm going to check it with negative 1, 1. So I'm going to grab negative 1, 1 and check it there. So check negative 1, 1. Negative 4 times negative 1 is positive 4. Positive 4 minus 3 is positive 1. Yep, it works. So we have the correct equation of the line. I feel very good about that one. All right, that was easy. Let's do line number 3. Line number 3, we don't see where it crosses the y-axis, so we have to just go through the ordered pair process here. So what is the ordered pair for this one? It's going to be 5, negative 4, 5 for x, negative 4 for y. What is the ordered pair here? It's going to be 8 for x and negative 3 for y, 8, negative 3. And you could do another point, but you don't really need to. And so once I have those 2 points, ask yourself, what is the slope? So the slope for this line is that you're going to go up 1. And let's see if I can make that look a little prettier. And to the right, looks like 3. So your change in y, make that look prettier. Your change in y is positive 1. Your change in x is positive 3. So change in y over change in x is going to be 1/3, right? Remember, gradual slopes between 0 and 1 absolute value. It's going up from left to right. That makes sense, right? It's a 1/3 slope, positive. So our slope for this one is just going to be m is equal to 1/3. I guess we can write in the slope for the other one. I forgot to write it in. So m is equal to negative 4, just so you guys have it. And anyways, let's get back into this one. So to find the equation for this line, because we don't have the y-intercept, we're going to use the process here where we have the slope, which is 1/3. We have one of the ordered pairs, which is 5, negative 4, let's say. So we have an x and a y and an m. We got to find the b. So let's plug into y equals mx plus b and find the missing value. So in this case, it's going to be y negative 4 is equal to m 1/3 times x 5 plus whatever the y-intercept is, b. So negative 4 is equal to 5/3 plus b. That's negative 4 is equal to 1 2/3 plus b. And then when you subtract 1 2/3 from both sides to solve for b, you're going to get negative 5 2/3 is equal to b. So does that look like a reasonable answer? Let's just go back to our line. If we move the slope, so up 1 to the right 3 is the same as down 1 to the left 3, down 1 to the left 3, down 1 to the left 1, 2, 3. So if we were to extend that line out right there, does it look like it's going to cross right about there, which is going to be negative 5 2/3? Yeah, that looks pretty good. All right, cool. So I feel like we definitely have the correct y-intercept and the correct equation for the line. This line will be y equals 1/3 of x and then minus 5 2/3. Okay. Now to check this one to make sure we didn't make any silly mistakes or boo-boos, we're going to do the other point, which is 8, negative 3, and we'll check with that. So let's just do a little check with 8, negative 3. And so 8 times 1/3 is going to be 8/3, which is the same as 2 2/3. 2 2/3 minus 5 2/3 is -3. That's correct. All right, so we know that we got it right. Awesome. So now we're going to solve the systems, right? So we got a system of equations here with lines 1 and number 2. It says, where do lines 1 and number 2 intersect? In other words, what's the solution to both lines? What's a point that's on both lines? So let's just go and see if it's the easy way to solve it. If there's an easy way to solve it, if you extend the lines, you'll see where they cross. So let's just see what happens here. I'm going to do a little bit of investigation. If I extend the blue line up, so we know the slope is down 4 into the right one, which is the same as up 4 into the left one. So let's go up 1, 2, 3, 4, and left 1. You guys can see that it perfectly matches right there, right? So that order pair, -2, 5, is on both lines. So this is one of those ones where it's really easy because we can see where that line intersects, right? That's going to intersect if we extend it out, following the slope up 1, 2, 3, 4 to the left 1. We can see exactly that point. So this is the solution to the system there. So we don't have to do any like algebraic investigation there if we don't want to. We could check it if we had extra time, but there's no need to. It's very clearly, obviously, that -2, 5 order pair. So where do lines 1 and 2 intersect? At -2, 5. Okay, and the other one's a little trickier. It says, where do lines 2 and 3 intersect? Now, if we look at lines 2 and 3, we've already extended this one, so we kind of know generally where they cross, right? So if I were to extend this line out, you guys can see kind of how it extends. Notice that it doesn't cross at a exact grid mark like the previous one. Right? The previous one, when you extend that blue line out, right, it's like, oh, beautiful, we extend the blue line out, and all of a sudden it literally goes through exactly that point, right? So we can just like go, oh, it's obviously right there. Right? That's very clear that that's where like, the two lines cross. Right? It's not the situation with this one down here. With lines 2 and 3, it's somewhere between 0 and 1 on the x-axis, somewhere between -5 and 6 on -6 on the y-axis. I know generally where it is, but I don't know exactly what it is. So this is where you'd use algebra, right? So this is how you can use your algebra skills. So now you're going to jump in here and do your algebra skills. And the way that you do this, just add a little grid paper for me here. Yeah, that's fine. You can authorize that. All right, almost done. There we go. Grid paper should be appearing. All right, so we're going to go through and do some algebra here. Now all you need to do is take the equation of line 2 and the equation of line 3 and basically use substitution to find the missing value here. So let's do that. I have, that's funny, I already have this graph paper that I can use. So I'll just use that. So this one's for version 5. Let's do another exact process here for version 6. So let's kind of go up here. So we got version 6. Let me do this with like black so it doesn't look weird. All right, version 6 here. This is lines number 2 and line number 3. Okay. Now in order to do this, we need the equation for line 2 and 3. So line 2 is -4x minus 3. So that's going to be negative y equals -4x minus 3. And then line number 3 is y equals 1/3 x minus 5 2/3. Y equals 1/3 x minus 5 2/3. So when you're doing this type of algebraic problem, you're trying to solve a system of equations. So you're given two linear equations. How can I find where these two intersect? Like, what's the ordered pair that's a solution to both of them? What you're going to do is you're going to use substitution just to set one y equal to the other. Because what that will do is it'll tell you the x position of where the y's are the same. So if you take, let's say, this y value, and you replace y over here with that, right? We substitute it in, right? We replace it. Then all you're doing is basically figuring out where the y's are the same, right? Where does this y on the left equal this y on the right, basically? So that's going to be the x position where the y's are the same. And the nice thing about that is it's pretty easy to solve once you're comfortable doing it. So let me show you how it works. So basically, you're going to then get -4x minus 3 is equal to 1/3 x. And I'm going to change this from a mixed number into a top-heavy fraction just because it's easier to work with. So 5 times 3 is 15 plus 2 is 17. So minus 17/3, okay? The next thing I would do if I were you guys is I would then multiply the whole thing by 3 to get rid of all our fractions. So what you get is a negative 12x. 3 times negative 4x is negative 12x. 3 times negative 3 is a negative 9. 3 times 1/3 x. 3 goes into 3 1 time. 1 times 1x is 1x. And then 3 times negative 17/3 is 3 goes into 3 1 time. 1 times negative 17 is just negative 17. Once you've done that, you want to get all your x's to one side, all your numbers to the other. So I would add 12x to both sides. And then if you're bringing your x's to the right, let's bring the numbers the other way. So add 17 to both sides. And what you're going to get there is 8. So negative 9 plus 17 is 8. And that is equal to 13x's. Okay? And now you want to undo times by 13, so divide by 13 both sides. And you get x is equal to 8/13. So that's a really funky answer, right? Okay. So what does that mean? It means we think that the line intersects at the ordered pair 8/13 comma something. Now we have to figure out the y value of that intersection point. So then take that 8/13 and plug it into either line to solve. Let's just plug it into the harder one to start. So we'll do y equals 1/3 x minus 1/3, not x, 1/3 times 8/13. And then minus, and then this one we'll just do 5 2/3. Okay. So that's going to be 8/39. So this is going to be y equals 8/39 minus 5 2/3. Now, when we look at 5 2/3, we can write 2/3 out of 39. So 3 times what would equal 39? 3 times 13 is 39. So that's going to be 39ths. As long as we times top and bottom by 13. What's 2 times 13? 26. So this is the same as negative 5 and 26 39ths. And so now we can do a little comparison here. Who's going to win? The negative by how much? So it looks like the negative is going to win by 5 is going to stay 5. And then 26 take away 8. 26 take away 8 is 18. So you're looking at 18/39ths, which is the same as simplify that negative 5 and divide top and bottom by 3. You're looking at 6/13ths. Okay? So it looks to me like our answer is going to be the order pair 8/13ths and then negative 5 and 6/13ths. All right? And let's go up here and put that in. So 8/13ths and then negative 5 and 6/13ths. And let's see if that's reasonable, right? We said that we knew vaguely it's going to cross somewhere between 0 and 1 on the x-axis. Is that between 0 and 1? Yes. And somewhere between negative 5 and negative 6 on the y-axis. Is that? Yes. So we can see that is a reasonable answer. But let's say we want to be 100% sure that we didn't make a boo-boo, right? Now you just take that order pair that you have there and just going to check it with the other equation here. So we know that it's a solution to the number 3 line. Let's see if it's a solution to number 4. Number 2, I should say. So let's do a little check here. I'm just going to check it. So we know that negative 5 and 6/13ths, the y value, should be equal to negative 4 times 8/13ths minus 3. So let's see if that's true. Negative 5 and 6/13ths, is that equal to negative 4 times 8 is negative 32. So negative 32/13ths. And then this would be minus, then 3 times 13 is going to be 39. So 39/13ths. And so this is going to be two negatives added together, basically, right? Negative 32 and 13ths plus a negative 39/13ths. So you're going to get negative 5 and 6/13ths is equal to, and how many is this going to be? It's negative 60 plus 11, so 71/13ths. And then 13 times 5 would be 50 plus 15, or 65. So when we do this, we get negative 5, and that would be 65. And how far is from 65 to 71? You're looking at 6. So notice it is the exact same. So it is a weird number, right? Obviously, these order pairs are a little bit funky, but we definitely can see that it works, right? It's a solution to both lines, and that's what a solution to the system is, right? It's an order pair that exists on both lines. It makes sense with the graph. It all fits together. This is what the answer is. And that's how you do the problem. Hopefully, you guys all got that, and it makes sense to you guys. And I will see you next time. So I can turn this thing off. Bye.